Okay, so what we've been talking about the last 2 weeks is simple interest. And recall, simple interest follows that formula that interest equals principal times rate times time. Let's, for example, let's say we had, you borrowed $4,000 at 6% for 3 years. Using simple interest, the amount that would be owed at the end of the 3 years would be found by finding the interest, which is going to be the $4,000 for principal, times 0.06 for the interest, for the rate, and the time is just 3 years. Well, that's going to give us $720 in interest, and we would add that on to our $4,000 to get a total of $4,720 that was due at the end of the 3 years. But that's simple interest, and as we said, that is the simplest way interest can be calculated. Not very practical. It's used in the short run, 120 to 180 days. Not very often that it's going to get used for 3 years. Normally what will happen in 3 years, actually anything over 6 months for the most part, they're going to use compounding. And what compounding is every little while they're going to take out, or they're going to figure out the interest and they're going to add it to the balance. And then from then on, the new interest is going to be calculated on that new balance. So the reason it's compounding is there is interest on top of interest. The interest is compounded on top of itself. There is some vocabulary we're going to deal with in here. What we talk about for an interest rate is always an annual rate, sometimes called an APR. APR stands for annual percentage rate. But then there's going to be an effective rate. The effective rate, because the interest compounds, you're getting interest on top of the interest. Effectively, you're getting a slightly higher rate of interest than what's stated. If you're saying it's 6% interest, you're actually going to get slightly more than 6% because it's paying interest on the previous interest. That is sometimes called the APY, for annual percentage yield. There's going to be something called the periods. In compounding, there are all sorts of different periods, lengths of periods. There could be per month, could be quarterly, quarters, could be semi-annually. Semi-annually, of course, is just every half year, twice a year. Daily compounding. We're going to talk about something called continuous, which we're not going to do a lot of because it's silly. But there are some of the fancier banks that do continuous compounding interest. And then there's just simple annual, which is just compounded once a year. Now, with those periods, we sometimes talk about a rate per period. And what that's talking about, let's say that we have that 6% interest we talked about earlier, but it's compounded quarterly. Quarterly means how many times per year? 4 times a year. So the 6% we said is an annual rate. The stated percentage is always an annual percentage rate. So the rate per quarter or per period would be 6% divided by 4 periods in a year, or 1.5% per quarter. This is why most of your doctor's offices and stuff like that charge 12% interest on any unpaid balance. Why do they do that? Well, how often do they bill you? Monthly. 12% annual interest comes out to be 12% divided by 12, because there's 12 months in a year, or 1% per month. So it's pretty simple for them to figure out. So now let's look at compound interest. Going back to that first example, $4,000 for 3 years, it's 6%, but this time instead of 6% simple interest, we're going to state 6% compounded quarterly. But we're just going to use the simple interest formula for now to work this out. So we're going to look at quarter number 1. In quarter number 1, we start out with $4,000. So our interest, right, is going to be on $4,000 times 6%, 0.06, but it's quarterly, so we're only looking at 1 quarter, or 1/4 of a year. So we calculate that out, we're going to get, what does that come up to be, like $60 interest? Look right? So what that means is we take the 4,000 plus 60. We start out quarter 2 with $4,060. So the interest for quarter 2 is going to be $4,060 as the principal, times 0.06 times 1/4. And what does that come out to be? So it's $61.20, look right? No, sorry, $60.90. There you go. Just not would use a calculator tonight. $60.90. So what that means is at the end of quarter 2, we've got the $4,060 plus another $60.90. Now you can see here the amount of interest already went up by 90 cents. We add that on, that's $4,120.90 is the balance to start quarter 3. How many times are we going to have to do this to get through 3 years? 12 times. 4 times a year for 12 years. Or for 3 years is 12 times. I don't want to do this 12 times. I don't want to put in that much effort. But let's take a look at what's happening here. We have this percentage right here. We mentioned the rate per period. Well, we're taking 6% times 1/4 is 1.5%. 4.015 is a rate. That's the amount of interest we're charging per quarter. Now, when we talked way back at the beginning of the semester about percentage increase or decrease, and even when we're talking about markups and markdowns, we talked about having the original amount, which was 100%, adding the new amount, or the increase, in this case, 1.5%. So what we end up with is 101.5%. Is what this is the beginning of the quarter, and this is at the end of the quarter. Let's take a look at that. If we used 101.5%, what would that be as a decimal? 1.015. If we take 4,000 times 1.015, what do we get? 4,060, which was our balance at the end of the first quarter. If we take 4,060 times 1.015, what do we get? Perfect, $4,120.90, which was the balance at the end of our second quarter. How many times are we going to have to multiply by the 1.015? 12 times, 12 quarters in 3 years. If we're multiplying by the same number over and over again, we have a shortcut in math for doing that, which is not squaring, but similar, a power, right? So this is going to be 4,000 times 1.015 to the power of 12. Careful. 782.47. Where's the caret key? This key right here.
Okay.
But my color really sucks up there, doesn't it? Showing nice and red on my screen. And your calculator should be on the left side, like halfway down. Okay. Now to make this work a little better, make this a little more universal, we want to understand what's going on right here. What that really is 100% plus our rate per period. The way we would find that is we're just going to take 100%. Instead of 100%, we're going to use the decimal version, which is just 1, plus 6% was our annual percentage rate, divided by how many periods were there in a year? 4, because this one's quarterly. That is where that factor comes from, right there. So if I want to do a different problem and find what's called the future value, the future value, if you're looking at a timeline, you have now, and you have the end of the term of this, the future value, which is usually just abbreviated FV, is that value at the end, in the future. The value right now would be the present value. So in that last problem, the $4,000 that we started out with was the present value. And we found the 4,782 was the future value, what it would be worth in the future. Well, let's look at another example. Let's say that you are going to borrow $8,000 for 2 years at 18%. Let's say your credit really sucks. And let's say it's credit cards. So it's going to be compounded monthly. So basically what we're looking at, 18% is actually a pretty low rate for credit cards. Most of them are 19 to 24%, some of them up to 29. The worst one I saw was last year. I had a student who had one that was at 34%. I didn't believe him. I made him bring it in and show it to me. Let's say you put an $8,000 balance on a credit card. 18% is actually not a terrible rate for a credit card. And you let it sit there for 2 years. How bad are you going to get hurt by that? Well, the future value is going to be the present value times 1 plus that annual percentage rate over N is what we put in for the number of periods per year. And up here we're going to do N times T, which is the number of periods per year times the number of years. T is the number of years. So that means for this problem, it'll be, my future value will be 8,000 times 1 plus 18 as a decimal, 18% as a decimal would be 0.18 divided by compounded monthly, so 12 to the power of 2 years compounded monthly will be 24 months, 24 periods. So let's practice punching that in. It'll be 8,000. Most of your calculators, you do have to do times before you put in the parentheses. So parentheses 1 plus point. Yes, you do. Yeah, you do. Otherwise, it messes up the power. So parentheses 1 plus 0.18 divided by 12. Close your parentheses to the power of 24. Equals 11,436.02. So over 2 years, that $8,000 just cost you almost $3,500 in interest. Takes about 4.5 years at 18% interest to double the balance. That green isn't showing up very well tonight, is it?
Wait, that's green?
Color's all off.
Yeah, the color's horrible. Well, I had asked him to replace the cable, just haven't got to it yet. Let me see if I can. Everybody punch that in and get it to work. Cool. So Just think of it this way: it's kind of like that Easter egg coloring that's supposed to look green on the egg, and you dip it in, and it comes out like lime. Okay, well, I'm going to have you guys try one. I want you guys to find the future value of $1,800 invested. Calculation will be the same as if borrowed. Invested at 8% compounded quarterly for 5 years. Tell me where to start.
1,800
So 1,800 times parentheses 1 plus 0.08 divided by 4. You got to close the parentheses and then to the power of 20. Because it's 4 quarters in a year times 5 years. Just 20 periods. So you got to be careful. Quarterly means you're looking at 4. Yep. Yeah, it's really easy to jump into the 12 for 12 months. Now let's see what you should have come up with. How many of you got 26, 74, 71? How many of you think you could have got that if you'd have done it? Had the right numbers? How many of you have no clue what we're doing right now? Debbie's laughing. That's her in that group.
Good thing we can't hear her. Is the thing not working today?
What's that?
Is her thing not working today?
Her mic? No, it's working. Well, with this example, it's a good place to lead into another method that's sometimes used by this textbook, which I don't care much for, but my math lab tends to use it. On page 459 of your textbook.
Oh, dear God.
So anyway, 459. You'll see that there is a future value of a compound amount of $1. That is the future value table. If you don't have your book, maybe scoot over and look on with somebody. Or if you need to, I've got a couple extra books here if you don't like anybody else in the class. You'll get along for a minute. Okay. So the future value table on page 459. What this is if you know the number of periods, man, I wish I had a voice tonight. Sorry, guys. The number of periods is over on the left side here. So for this last problem, how many periods was there? 20. So you go down to 20 down there. And on top is the rate per period. This was 8% quarterly, which meant the rate per period was what? 8% divided by how many periods in a year? 4, so that meant 2% per period. So along the top, in our rate per period, we're going to look for 2%. So we find the 2%. We trace them down till they cross, and we get a number there in the 2% and 20 period, or 1.48595. Does that look right? That is our compound interest factor, or what my math lab will often refer to as the table factor. What you would do with this table factor is you would take $1,800 times 1.48595. So 1,800 times 1.48595, $2,674.71, which compares to the previous answer we had is pretty much exactly the same. Personally, I hate the table, and I'll show you for a couple of reasons. One is I never have the tables with me. I always have something that, even if I just have to pull it up on my cell phone, I have something that can be used as a calculator almost all the time. So using the formula is so easy, why would I mess around with the table? The second reason is this table value is rounded off. When we calculated this up here, remember this was actually 2674.705. So, I mean, if you get into some larger numbers, that round off value in the table gets to be significant. You can be off by 10, 15 cents. Another reason why I dislike the table is, let's have you do this one. I want you to do $4,500 at 8% compounded monthly for 10 years. How many periods? 120. 10 years times 12 periods, because it's monthly, would be 120 periods. Rate per period? 8% divided by 12, which gives us 2/3%. Neither one of those is on our table, is it? So the table sucks. But for our formula,
For my math lab or whatever, we can use the formula. We don't have to use the table. It's just
my math lab will push the table on you. If you want to use the formula, go ahead. If your answer's off by 2 or 3 cents when you go to double check your answer, you'll know that's why. It's a round off error. On the homework, don't worry about it. If you're within even 4 or 5 cents, you did it fine. On the quiz, if it's wrong and when you go back and double check it, you're within, like I said, 4 or 5 cents, let me know and I'll look at it and I'll change that grade. Because I would rather have you use the formula than the table anyway. The table is approximate, but my math lab does use the table for everything. But anyway, if we wanted to use the formula for this, like good smart people do, it's 4,500 times, parentheses, 1 plus 0.08. I'll erase that so I should read my handwriting. 0.08 divided by 12, close parentheses, power of 120. And we get $9,988.38. What do you think? Need to be a banker? That is pretty good interest for 10 years. Well, it is 10 years, though. Your money should pretty much double in 10 years. And it did, a little bit more. That is something they call it in banking, they call it the rule of 72. If your interest times your years comes up to 70, for example, this was 8%. So if you take 72 divided by 8%, you get 9. That means it's approximately 9 years for your money to double. You'll see this in 10 years, this a little bit more than doubled. So that is finding the future value. Just like with dealing with the simple discount notes, where the actual effective rate was larger than the stated rate because you didn't get the full amount of money. Here, there's an effective rate. It's larger than the stated rate because of the compounding. When we're talking about effective interest rate, however, unlike the simple discount notes where we use the whole term of the note for the effective rate, when we're talking about compound interest effective rate, we only go for 1 year. So let's say that you're going to invest $8,000 at, and let's go back to our 6% compounded monthly. find the effective rate. Now you might be looking at that thinking, hey, there's something missing there. What seems to be missing?
How many years?
How many years? Do we care?
No.
No, we're not looking for a future value. We're just looking for the effective rate. When we're talking about effective rate, for compound interest at least, our time is always going to be used as 1 year. Unless it's actually the investment itself is shorter than 1 year. And we'll look at examples of that in just a minute. So that is a big condition there. By the way, that color I just put up there is supposed to be red. So anyway.
If you were to watch the video, it would actually come up as red.
Yes, it should come up as red on the actual video. Because that's all within my computer. That doesn't go through the network at all. So anyway, let's figure this out. First thing I'm going to do is step one is I'm going to find the future value at the end of 1 year. So what that means, taking our $8,000 present value, the current value, times 1 plus 0.06 divided by 12 is monthly, to the power of 12, because we're only going for 1 year. This gives us 8,000 times, parentheses, 1 plus 0.06 divided by 12 to the power of 12. So at the end of that period of time, 8,493.42. Do you concur? Yes? Okay. That's step one. Step two. Find the amount of compound interest. In other words, how much interest has been added to this account? Well, $8,493.42 is the future value minus 8,000 that we started with. Is $493.42 in interest, in compound interest. Step three. Back to the simple interest formula to find the effective rate. So I equals PRT. Where we know that the interest is $493.42. The principal was $8,000. The rate is what we're looking for. Our time was 1 year. Very good. So what this becomes is, I'm just going to skip the step of 8,000 times 1 because most of you in your head could probably figure out that's 8,000, right? Okay. So we're going to divide by 8,000. So $493.42 divided by 8,000 gives us 0.06168 is our rate. Now let's say I want you to round to the nearest hundredth of a percent. Am I ready to round this right now? Say no. What do I have to do before I round it? I have to make it a percent by moving that decimal over. So this is 6.168%. Now to the nearest hundredth percent. This is the tenths. Here's the hundredths place. The 8 tells me that this rounds up 6.17%. Questions?
Okay, this is probably like a third grade question, but, okay, so the decimal moved over 2 times is 100?
Yep, for the percents, yep.
No,
Oh, down here, yeah, so this is the tenths and this is the hundredths.
Okay.
So then you have to round off there, yep. I want you guys to try one. Find the effective rate for $2,500 invested at 10% compounded quarterly for 7 years. Remember, when we're dealing with effective rate, you only care about 1 year. So that 7 years, I put in there just to be mean. I have to do it a few times a night or I don't satisfy my contract.
Well, yeah.
The other ones, other than that, are just for my fun.
How do you divide it before it's still 4?
So you're looking at a future value. Remember, future value at the end of 1 year is your first step. So that's going to be the 2,500 times 1 plus, bless you, 10% is 0.10 divided by 4 because it's quarterly to the power 4. Bless you again.
There is power 20, like 29%.
Yeah, you only raise it to the power of 4. So you got 2,500 times 1 plus 0.1 divided by 4, close parentheses to the power of 4. So at the end of 1 year, we have a future value of 2759.53. Everybody get that for their 1 year future value?
No.
No? Now you did, right? Now I did, okay. Because remember, that first step, that is the vital part of that first step, is future value after 1 year, unless it's less than a year. Our next example is going to be shorter than a year. What's step 2?
27.59.
Find the amount of compound interest, which will be just that 2759.53 minus the original 2,500. So that's going to be $259.53 in interest. Step 3. You got it. I equals PRT. So the interest is 259.53 equals the principal of 2,500 times our rate, which is what we're looking for, times our time of 1.
Oh, you go 2,500? I thought you did 27.
Nope, 2,500 was the original amount. Always back to the original, the present value. So this is just end up going to be 259 divided by 2,500.
When doing effective rate, is it always going to be 1 there?
Not always. I'm going to show you an example. If it's less than a year, then it won't be a 1 there.
Okay, then why do you only do to the 4th power and not 20?
Because when you're figuring out effective rate, you only care for the interest for 1 year. So the 7 years was just me throwing in extra information to see if you'd catch it.
What are we rounding to?
So we're going to round to the nearest 100th of a percent again, since I didn't say anything. So I always go to at least 5 decimal places when I'm writing down my rate. So this will be 0.10381. That's a rate yet, so to make it a percent, we got to move it 2 spots. That'll be 10.381%. Rounded to the 100th of a percent. Well, this is the 10th. This is the 100th. We're rounding there. The 1 tells us it stays as an 8. So 10.38% is our effective rate. Not yet. I still got 2 minutes. Find the effective rate. For an investment at 9% compounded monthly. Now it's break time. We'll come back and discuss the answer to that when we come back.